Are we all ready for our next segment?
We are ready.
Can you go ahead and intro the name?
Right. Next, we're going over to Joel Siegel's Science Center.
All right, well, welcome to the science segment with the science enthusiast Siegel. That's me. Isn't that wild? Today, we're going to talk about a few topics, since it's roughly end of the This right here is the center of our solar system, what all the planets revolve around, which is the sun. It's our star. Keeps us warm, makes daytime happen, all sorts of things. Now, back when I was in school, there were 9 planets. Since then, things have changed a little bit. Now it's debatable if there's 8 or 9 or more. We're still not really entirely sure. Anyways, let's go down the line. This little guy right here is Mercury. He's closest to the sun. Not real close, but close. Next, second in line, is Venus. Venus is kind of like a gassy giant. It's theorized that Venus was actually 2 celestial bodies that had crashed together and not fully formed an actual planet, and all the gases that escaped have stayed within its gravitational field. Third in line is our home. We know it as Earth, our little satellite, the moon. Fourth is the big red planet, Mars. Then you actually have a lot of space in there, and there's an asteroid field as well. Then comes the biggest planet in our solar system, Jupiter. This guy has a giant red swirling storm on it. Then there's Saturn. Saturn, you know, they have the really cool rings that go around it. Then over here, 7th in line is Uranus. Starts with U and ends with us. It has a ring that goes up and down. Then 8th in line is Neptune, a giant icy, watery planet. And as I said, 9th was Pluto, but Pluto has been demoted. Oh well, bye Pluto. These are the planets of our solar system. A solar system is a grouping of planets, celestial bodies, that revolves around the sun. Now, revolving around the sun, imagine my fist is the sun. Planets would go around it like this. They orbit. They revolve around the sun. One revolution is 1 year for that planet. In our case, it takes 365.25 of our Earth days to do one entire revolution around the sun. Varies from planet to planet. As the closer you are in, the smaller the orbit, further you are out, the larger the orbit. Earth is at the perfect distance to support life. We have water, we have land, we have sun, which warms us and gives us our day and supports life. Next, we have, let's talk about the planet Earth. The planet Earth, it's really, really cool. And you may see it here. It's all the good stuff on the outside. But the planet Earth actually has layers. We draw a cross-section of it. The outermost layer, this is the fun one, it's really, really thin. And it is called the crust. Isn't that wild? I know, see? There's the crust, then there's, let's see, that's terrible, the mantle, which is just under us, much, much, much bigger. And then inside of that is actually the core. There's an inner and outer core. The core is mostly nickel and iron. The mantle is lava, liquid magma, liquid earth, basically. Now, we live out on the crust, as I said, right there. And the crust is actually broken up into a whole bunch of different bits, which are known as plates. Now, plate tectonics are the plates moving over the mantle. Now, there are two different types of plates. There's oceanic and continental. Oceanic have a higher density than the continental plates. And as these plates shift and move, that's when we get stuff like earthquakes. Now, oceanic plates, when they collide with continental plates, they will go under and back into the mantle, and they will start to boil up and turn back into Earth. And when that happens, vents appear in the continental and create volcanoes. So spilling lovely lava everywhere. Now, when two continental plates collide, since they are both the same density, they create mountains. All right here. We know a lot of these mountains, like the Rockies, the Himalayas, Appalachians, a lot of those have existed over the years from plates colliding. Sometimes, when oceanic plates split, they create a ridge of underwater oceanic volcanoes, which will erupt, and the lava and magma will surface, creating new islands. Some of the Earth's newest islands are the Sandwich Islands, which you all know as Hawaii. Those guys are brand new Earth. There's still an active volcano in Hawaii as well, known as Kilauea. So, these are the lovely layers of the Earth. The Earth, being a celestial body, is so big that it has a force that is called gravity. Brings everything in, pulls stuff in. Every one of these celestial bodies has gravity. Even our moon, as a matter of fact, has enough gravity that it pulls the waters of the Earth, creating the tides. Now, what is gravity, you ask? Well, gravity, as a matter of fact, one scientist had found out at the Leaning Tower of Pisa. His name was Galileo Galilei. He had found out that dropping ball bearings of varying sizes off the top of the Leaning Tower of Pisa, that they fell at the same rate. What's that rate, you ask? I'm glad you asked, truly.
What's that rate?
See, there you go. Those are my assistants of science.
Science, science,
Is
science.
9.8 meters per second. So, everything on Earth falls at 9.8 meters per second, unless it's either it has a lighter density than air, or it's able to manipulate throughout air, like having resistance and things like that. Things that have resistance are stuff like airplanes, birds, even space shuttles can actually escape Earth's gravity. Each of the different planets in our solar system has different gravity. So it's a lot lighter on the moon. If you've seen videos of astronauts on the moon and how they bounce around, it's because gravity there is a lot lower. It's really, really minimal in comparison to the planet Earth. Now, gravity, as I said, is the thing that pulls everything down. So you can go outside and play sports, baseball, football, basketball, and gravity actually is your best friend because of it's what makes the ball come back down. Gravity brings everything down, everything in. It even helps with some toys, like slinkies. When you go to play with a slinky, the reason it actually falls downstairs is because gravity has a pull on it. But when it comes to gravity, just don't let it get you down. Our next segment, as a matter of fact, is about rocks. Types of rocks. I know you're interested in this, seriously. Not gonna lie. Geology, it rocks. Well, There are three major different types of rocks. There's igneous, there's metamorphic, and there's sedimentary. Igneous rocks are rocks that form when a volcano erupts, when there's separating tectonic plates, things like that. They can form inside the crust, or they can be exploded out. Some igneous rocks are things like granite, or basalt, pumice, obsidian, and they are formed, as I said, generally during eruptions of volcanoes, liquid magma, all sorts of things like that. So sometimes they get some pretty interesting patterns and things like that. Next are the metamorphic rocks. Metamorphic rocks are pretty darn cool as well. They are formed through pressure and force and heat, like in the shifting layers and plates of the earth. They are formed, and they make various certain things like, let's see, what do we have? We have marble, quartz, all those guys end up being some that are metamorphic rocks. Then, the super coolest rocks, actually lead into our next segment, are called sedimentary. Now, you may ask, hey, science enthusiast Siegel, what's sedimentary?
Hey,
Well,
science enthusiast Siegel, what's sedimentary?
I'm glad you asked. If you break down the word, sediment is inside the word sedimentary, and that means things that settle. So let's say there's stuff like sand, clay, silt, dirt, salt, all these things. When they settle and they form together real tight, they create stuff like sandstone. This guy is a sedimentary rock. Sandstone, conglomerate, limestone, all these guys are sedimentary rocks. Now, the sedimentary rocks are usually found at the bottoms of major waterways and things like that, which major waterways and sedimentary rocks actually help create fantastic things that we know as fossils. Ooh, ah. This is my fossil fish of science.
Science!
Of which I actually uncovered this guy in college. We were given slabs of rock and told to pick at them until we found the fossil inside. Came from Fossil Butte, Wyoming. Now, fossils, you may think that they're actually bones.
Are they bones?
Well, they're not. Thank you for asking that, student Ed.
Are they not bones?
They are not bones, as a matter of fact. In sedimentary rock, you find these fossils, which are more like shadows or silhouettes of the bones that had existed once. Now, in the layers of the earth, within the crust, water flows underneath us pretty much at all times, called groundwater. When a fish, a dinosaur, a plant, a creature passes away in or on a riverbed, right near a riverbank, stuff like that, its body begins to decompose. And as it decomposes, it settles into the sediment, the bottom of all that. So the clay, the silt, the mud, the sand. It settles into that, and it continues to decompose. But as it gets put into that layer of sedimentary rock, like this limestone, the groundwater decomposes the body, but it doesn't fully decompose all the bones. What it does instead is it takes out the bone and leaves minerals in its place, thus casting a shadow, like a fossil of a fish, or fossils of plants, or things that we know like fossils of dinosaurs. Now you may ask, what's a dinosaur?
What's a dinosaur?
Well, I'm glad you asked. Go to your nearest movie theater and you can find out what people think are dinosaurs. But in actuality, yes, in actuality, dinosaurs are creatures that roamed the earth millions of years ago. Because the earth, as a matter of fact, is actually billions of years old. I know, it's a real old thing.
I heard 6,000 years old.
Oh, well, that's strange and wrong, but it's okay. So, dinosaurs are these creatures that look somewhat reptilian, that had roamed the Earth over 65 million years ago for somewhere near 200 million years in an era called the Mesozoic era, which was separated into three different periods for the Jurassic, Triassic, and Cretaceous period. Most of the dinosaurs that you see here were actually from the Cretaceous period. Some are from the late Jurassic. And dinosaurs, the reason that we actually know about them is because of fossils. Now, when dinosaurs had passed away and started to become fossils, we learned of how they died based on where they died, how they lived, things that they may have eaten as to be, stuff in their stomach and things like that. As a matter of fact, there's even fossils of dinosaurs, what's called gastroliths, which are actually stomach stones, digestion stones, and coprolite, which is fossilized dinosaur poop. But, more seriously, these guys are fun-loving little dinosaurs, which none of this is to scale. As a matter of fact, most of these are way bigger. As a matter of fact, there's a guy called the Apatosaurus, and he is much, 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 much bigger. Probably numerous school buses long, and maybe a small building or two high. But one of the cool things we learned about dinosaurs when we were finding their fossils is that a lot of them have different shaped teeth. There's guys that have sharp teeth, like this. And there's guys that have flat teeth. These guys have flat teeth. These guys have flat teeth. And that made the major difference between them. The guys with the sharp teeth, they ate meat. All sorts of meat. Other dinosaurs, other creatures, crazy little critters. And the plant guys ate all the plants. So, dinosaurs are super duper cool. This is one of my personal favorites. He was a big guy that ate a lot of meat, known as a Tyrannosaurus rex. And there's also a Velociraptor, Stegosaurus. This here is a Parasaurolophus. He was a plant guy, kind of one of those duck-billed ones. There were even flying ones, like the pterodactyl, known as pterosaurs. Now these guys, it's theorized and more or less pretty much discovered that dinosaurs may have in fact had feathers on them, not actually been reptilian like we've always thought them to be. So the T-Rex could have looked something like a really giant turkey. I know, hold your laughter, it's okay. But, thank you. But you don't see these guys anymore. I mean, you may see turkeys, sure, chickens, other birds, but you don't see creatures that are this huge. That's because a mass extinction happened. It's theorized, one of the most believed theories, that an asteroid flew through space. Here, we'll use a rock. Like this guy. Flew through space and hit the Earth. Causing all sorts of debris, smoke, gases, and things to fill the Earth. And it pretty much killed almost every living thing on Earth. That's, as I said, just a theory. Now, others are that all the dinosaurs evolved and turned into other things. As we said, they could be birds nowadays, but no one really knows for sure. As long as we continue to study fossils within the sedimentary rocks throughout Earth, we'll continue to learn, because the present now is the key to the past. Thank you for watching my science segment. I hope you guys have learned that I'm not actually a scientist.
Science, 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 science.
Don't forget, donate in the name of science.
Science, 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 science.
Or in my name. That works.
Joel, 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 Joel.
Siegel, 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 Siegel. So catchy.
Oh, I thought you were saying single, 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 single. I was like, aw.
What a jerk. Are you kidding? This neighborhood? The neighborhood where Joel lives, they love the bow ties. This guy is never single.